Hello, friends. In our today's class, we are going to learn about atomic structure. What is atomic structure? Atomic structure has to do with the way atom looks like, how the particles are arranged in it. We are going to start from the first 20 elements. The first one is hydrogen atom. When we're done with hydrogen atom, we'll go to helium atom. When we're done with helium atom, we'll go to lithium atom, beryllium, boron, carbon, and so on and so forth. So as I said earlier, that the structure, atomic structure has to do with the way it looks like. Uh, Hydrogen is the first element in the periodic table with atomic number 1. So if I say hydrogen, that's the symbol with atomic number 1. Now it has a structure. If I like, I can say element. I can say structure, and I can say electronic configuration. So if I put it in this form, the first one is hydrogen with atomic number 1. The structure looks like this. You don't forget the nucleus. The center dot here is the nucleus, which contains neutron and proton. Apart from hydrogen with atomic number 1, mass number 1, that has no neutron. The rest atoms, they have neutron and proton in the nucleus. So if I generalize it, I will say in the nucleus, you have, this is nucleus, which contains, that is, proton and neutron. Proton and neutron, they are in the nucleus. So hydrogen having one proton will also have one electron. So this is my electron now. Electron. Remember, proton and neutron are in the nucleus. Now, I want you to note that proton is positively charged. Proton is positively charged. Positively charged. While electron is negatively charged. And neutron is neon. It has no charge. Has no charge. So note this. Proton is positively charged in the nucleus, while neutron is or has no charge. Electron is negatively charged and it is found on the orbit. So note that. So if that has been established, so this man now has one electron. So in the electronic configuration, you have one. Let's go to the next element, which is helium, He, atomic number 2. It has a structure of this. Remember, I said anytime I draw it and I put this center dot, I'm talking about proton and neutron. So, what my concern now is about the number of electrons that helium has, which are 2. Is increasing from hydrogen. Hydrogen atomic number was 1, helium 2. So number of electron 1, number of electrons 2. On the electronic configuration 2. So we move on to lithium, being the third. Atomic number is 3. So you have something like this. This is the nucleus. This, you have 2 electrons in the first shell. Note also that every first shell cannot carry more than 2 electrons, 2 maximum. So after putting 2, that shell is filled up. You create another shell and put the remaining 1 to give you 3. 1, 2, 3. And then coming here, that first shell is this one, which is K shell. Now, K shell is filled. Let's go to L shell. You put how many are left in on the second shell? 1. You put it there. So this shell is K shell. This is L shell. We will soon finish L and go to M and go to N. So after the first shell with 2 electrons, every other shell that comes in will carry maximum of 8 electrons. So now let's move on. Elements with atomic number 4. Hydrogen, helium, beryllium. Beryllium is Be, atomic number 4. The first shell will carry 2. The second shell will carry the remaining 2. And then you will now have electronic configuration 2 and 2. Now the next is, permit me to clean from top, or if I like, I can continue from this side. The next is boron, atomic number 5. Then the first shell contains 2, the second shell contains 3. I like putting them north, south, east, and west. Then the electronic configuration of it, the first 2 carries 2 here, the second shell carries 3. Then the next one is carbon with 6. Now coming here, you draw the first shell with 2 maximum, remaining 4. That 4 you put 1, north, south, east, and west. Then you have 2, 1, 2, 3, 4, comma 4. The next one is N. N is nitrogen, atomic number 7. Now you draw the first shell. Do not forget to put nucleus at all time. Now, how many are left? If you remove 7 from here, 5. Draw the second shell and put 5. 1, 2, 3, 4, 5. Now you put your 2 and 5. The next is oxygen, atomic number 8. You draw the first shell, 2 electrons are there. Draw the second shell. How many? Remove 2 from here, 6. Put 1, 2, 3, 4, 5, and 6. Then you have 2, 6. Fluorine is the next. F with atomic number 9. First shell with 2 electrons. Second shell with 7. 1, 2, 3, 4, 5, 6, and 7. Then you now put your 2 and 7. Okay, so I will one is neon Ne 10. You come here, first shell will carry 2, second shell will carry 8. 1, 2, 3, 4, 5, 6, 7, and 8. And here, come here, you have 2 and 8. That shell is filled. K is filled. L is filled. M is the next one. Now remember I said K, L, M, and N. So if you do that, next is sodium. Na11. The first shell, 1, 2. Second shell, 1, 2, 3, 4, 5, 6, 7, 8. 1 electron is remaining. Put it here. I can put it here. That gives me 2, 8, and the next one goes to M. The next is magnesium, Mg12. So if I use Mg, I will now have the first shell here containing 2 electrons, the second shell containing 8 electrons, the third shell containing, that's 10, 10 minus, that's 2 left. I can put 2 here. Then that gives me 2, 8, 2. The next is aluminium. Aluminium is 13. So you have the first shell with 2, have the second shell with 8, you have the third shell with 3. You put one here, put one here, put one here, and then you have 2, 8, and 3. So that is for aluminium. Let's do silicon. Silicon is Si, atomic number 14. Then you will have the first shell, 2, second shell, 8 electrons, third shell, 4 electrons. Then you have 2, 8, 4. Phosphorus is the next, 15, atomic number 15. First shell, 1, 2. Second shell, 1, 2, 3, 4, 5, 6, 7, 8. That's 10. 5 remaining. 1, 2, 3, 4, 5. So with this now, we can see 2, 8, 5. That's the electronic configuration. So you can do sulfur using this. You can do chlorine, argon, potassium, and calcium. That will take you to the first 20 elements. Now, having known all these electronic configuration, now the next thing we are going to consider today is isoelectronic ion, having different atomic numbers but with the same electronic configuration. For example, if I say helium, for example, has the atomic number 2, electronic configuration 2. Remember I said helium with atomic number 2 having electronic configuration 2 is isoelectronic with hydrogen that has borrowed electron in, and that is hydrogen ion. Atomic number is 1, but the electronic configuration of this is 2. If I say, remember the hydrogen ion that I'm talking about is not the one with plus. This is not plus but minus. So it has borrowed one electron to add the one electron it has to get the 2 electrons. Now, lithium ion, this one is plus. Remember the lithium that we just finished has 2, 1. After donating out 1 electron, giving out this, it remains 2 and plus because it has given out. This one carries minus because it has borrowed. Any plus means given out. Any minus means collecting. So this man has donated 1 electron out. Atomic number is 3. Atomic number is 3, but the electronic configuration is 2 because 1 has been donated. Beryllium has atomic number 4, but after, remember beryllium is like this. If it gives out this, it will carry plus 2 and it will now be what? This will now be its electronic configuration. Boron is B. Atomic number of boron is 5. If it has given out the 3 electrons on the outer shell, it will now be 3 plus, and the electronic configuration is 2. So all of them here are isoelectronic. Isoelectronic ions. They are all isoelectronic ions of helium. We can still move forward to and talking about the isoelectronic ions in terms of using, I can say the examiner can ask you to write isoelectronics of neon. If neon atomic number 10 is 2 and 8, isoelectronic ions, when you are looking for isoelectronic ions of a substance, look forward 2 to 3 elements above it in the first 20 elements, and then 2 to 3 elements below. Those below will borrow the number of electrons that will make them to be the same way, like neon here, and or give out the number that will make them to fall down to neon here, like fluorine. Fluorine is atomic number 9. It will borrow 1 in, and we have F minus because atomic number is 9. Now, electronic configuration means it has borrowed 1 to add to make it 10. And that borrowing of electron is only affecting the number of electrons and not the atomic number. So don't change this to 10. So you now have 2 and 8. If you go for oxygen with 8, it will borrow 2. That will be 2 8. If you go for nitrogen, that would be 7. It will be minus 3. That will now give you 2, 8. If you go for those ones above it, like sodium Na will, or with atomic number 11, will give out 1 to fall down the number of electrons to 10, which will be 2 and 8. If you go for magnesium, it will be plus 2 with atomic number 12 to give you 2 and 8. If you go to aluminium, 3 plus, that's atomic number 13, will give you 2 and 8. So all of these are isoelectronics. They are isoelectronic. Okay, so having known all of these, you can do isoelectronics. Give me 5 isoelectronics of argon. I believe you can do that. So without wasting time, I wish to stop the class here, and then until we meet again. Thank you.